Hello friends, a very warm welcome to all of you. Myself Amit Kumar Gautam, and today I will discuss the different nearest neighboring particles in a simple unit cell system or in the primitive unit cell system. In this one, the figure number 1 represent one cubic unit cell with the edge length A. Every edge of the cube has a dimension A, and we know that one cubic unit cell has the 8 corner, and in the simple unit cell each corner is occupied by one particle. Look, 1 2 3 4 5 6 7 and 8, all the corners of the unit cell are occupied by the particles. And we have to find out how many nearest particle we have in the surrounding of our A reference particle. For that purpose, I choose this green particle as my reference particle. With respect to this green particle, the particle red present at the edge. It is present at the corner of the edge, and we know since every edge length is the A, so dimension between the green and red particle is always A. Now these black particles, these are the particles those are present at the phase diagonal. If I join this line, black to green particle, this line represents the phase diagonal with the distance of A under root 2. Now this blue particle is the particle present at the body diagonal. If I join this green particle to the blue particle, we have one body diagonal, and this blue particle is present at the another corner of the body diagonal. And we know this distance of the body diagonal is always A under root 3. If I join this green particle to the blue particle, then we'll have one body diagonal. Dimension of the body diagonal is the A under root 3. In this figure number 1, green particle is my reference particle. All the red particles are present at the edge with the distance A. All the black particles are present at the phase diagonal with the distance A under root 2, and blue particle is present at the body diagonal with the dimension A under root 3. So again I will repeat for you. Green particle, our reference particle red, present at the edge length A. Particle black particle is present at the phase diagonal. The dimension from the corner to the phase diagonal is always A under root 2, and blue particle is present at the body diagonal with the dimension A under root 3. Then in the figure number 2, this figure represents a combination of the 8 unit cell. As you know, the corner of the cube, the particle which is present at the corner of the cube is the part of the 8 unit cells. So with the figure number 2, I am trying to represent a combination of the 8 unit cells, where the green particle again represent the corner, our reference particle. All the red particle represent the particle those are present at the edge length A. All the black particle these particles represent the particle as the phase diagonal, and all the blue particle represent the particle present at the body diagonal. Now we have to find out the first nearest neighbor. What is the meaning of that? How many particles we have in the immediate surrounding of the reference particle that I have taken green. First nearest neighbor also decide the coordination number of the crystal system. What is the meaning of the coordination number? How many different particles it has in its immediate surrounding, with how many particles it has the physical contact. So for the first nearest neighbor, we will discuss the figure number 3. In this figure number 3, the blue particle is our reference particle, and red particle, these are the particles present at the edge with the distance A. If you see, then with respect to this green particle, we have one red particle at the left side, one red particle on the right side, one particle top above and one particle below, one particle in the front and one particle at the back side. So this green reference particle is surrounded by the 6 red particles at the distance of A. This, how many number of red particle we have in the surrounding of the green particle, that quantity represent the coordination number or first nearest neighbor. So first nearest neighbor, which also decide the coordination number, is present at the distance of A. What is the information? It is present at the edge. And how many such kind of particle we have? We have 6 particle of such kind. Now we have to find out the second nearest neighbor. To find out the second nearest neighbor, we will discuss the figure number 4. In the figure number 4, again this green particle represent the reference particle which is present at the one of the corner of the unit cell, and these all the black particles represent the particle those are present at the face diagonal. 1, 2, 3, 4. Similarly 1, 2, 3, 4. For this purpose, I assume that this green particle is present in the 3 plane: x-axis, z-axis and y-axis. If we consider first the xz axis, this is our x-axis and this is our z-axis, this is our green particle. It is surrounded by the 1, 2, 3 and 4 particle in the xz plane. Now if I take the xy plane means x is this one and y is this one. So this is our x and this is our y, this is the x and this is the y axis. This plane represent the xy plane. Again green is our reference particle and it is surrounded by the 4 particle: 1, 2, 3, 4. Now last plane is the YZ plane. This is the Z and this is the Y. So again we have the 4 particle in this plane. How? Green is our reference particle and it is also surrounded by the 4 particle. How? 1, 2, 3, 4. So again it is surrounded by the 4 particle in the x, y, z plane. So in the xy plane, in the xz plane 4 particle, in the xy plane 4 particle, in the xz plane again we have the 4 particles. So total 4 particles become the 12. So second nearest neighbor are the 12 particle. Again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So second nearest neighbor is present at the distance of the a under root 2. What is the information? This is the face diagonal, and dimension of the face diagonal is a under root 2, and how many such kind of particle we have? 12. Now for the third nearest neighbor we will discuss the figure number 5. Again this green particle represent our reference particle and blue particle are the particle present at the body diagonal. So if I join this blue to green particle, we have one body dimension, one body diagonal of such kind. Means in the one unit cell we have one body diagonal of such type. This reference particle is present in the 8 unit cell, and in the each unit cell we have one body diagonal of such kind. So suppose this is the first body diagonal, this is the second, third, fourth particle, 4 particle downward, and 5, 6, 7, 8, 4 particle upward. So how many? Third nearest neighbor we have at the distance of the a under root 3. What is the information? It is the body diagonal. And how many such kind of particle we have? 8. So again to summarize, first nearest neighbor, also decide the coordination number. It is present at the distance of a. What is that? It is the corner of the edge. How many such kind of particles? We have 6 such kind of particles. Second nearest neighbor is present at the distance of the a under root 2. What is the information about that product? In that particle, it is the face diagonal. How many such kind of particle? We have 12 particle of such type. Then third nearest neighbor we have at the distance of a under root 3. What is the information? It is the body diagonal. And how many such kind of particle we have? We have 8 such kind of particles. So for this time, that's all from my side. Thank you.